All right, welcome to the Explainer. Today we're going to do something a little different. We're taking a single GCSE maths question and really digging into it so you can see exactly how to lock in every single mark.
Okay, let's jump right in. So here it is, question 16. It's a quadratic inequality, and it's worth a couple of marks. Now, our mission here isn't just to find the answer. It's about figuring out how to write it down perfectly, exactly how an examiner wants to see it.
All right, first things first, how do we get that first mark? Well, it all hinges on finding something the mark scheme calls the critical values. Let's break down exactly what that means.
So, picture this. You're in the exam, you flip the page, and you see this question. What's the very first thing that should pop into your head?
Well, lucky for us, the official mark scheme gives us a huge clue. It basically says the first method mark, what they call an M1, is all about finding these so-called critical values. So, what on earth are critical values? Simple, really. They're just the points where the expression equals 0. For this question, that means we need to figure out what value of x makes each of those brackets equal to 0.
So we just treat each bracket like its own mini-equation. Set it to 0, solve it. That gives us our two critical values, 3/4 and -5. And believe it or not, just by doing that, boom, you've already got the first mark in the back.
Okay, mark 1 is secured. Let's move on. Now, to get that second mark, we need to understand what these numbers we just found actually mean.
And this is where it gets pretty cool. See, these values, -5 and 3/4, they aren't just random numbers. They're actual points on a graph. Specifically, they're the points where the graph crosses the x-axis.
And think about it. If you were to multiply out those brackets, right? The 4x times the x, that gives you a positive 4x squared. And because it's a positive quadratic, we know for sure the graph is going to be a U shape, like a smiley face.
So let's bring it back to the original question. It's asking, where is this whole thing less than 0? What does that even look like on a graph?
Yeah, less than 0 is just a fancy way of saying below the x-axis. And once you see that, suddenly the solution becomes super clear, doesn't it?
Okay, so we've got all the pieces of the puzzle. Now we just have to put them together and write down the answer correctly to get that final accuracy mark, the A1. Just look at our little sketch. The bit of the U shape that dips below the x-axis? Well, it's pretty obvious it's the bit between our two critical values, right? Between -5 and 3/4.
So how do we write that mathematically? We write it as one single inequality. We say that x is bigger than -5, and at the same time, it's smaller than 3/4. That right there, that's your perfect full marks answer.
But hey, it's also good to know that the mark scheme is a little flexible here. You could also write it as two separate inequalities. X is greater than -5 and x is less than 3/4, or you could even use that little intersection symbol. Any of those will get you the final mark. So you've got options.
So what's the big takeaway here? It's that a super quick, rough sketch can turn a kind of confusing algebra problem into something you can just see. It makes it visual. Now that you've seen how powerful this is, where else could you use this little trick? What other tough inequality problems could a simple drawing unlock for you?